So the one thing we have to watch out here that I think is really important about understanding what's happening in these problems is that we kind of hope, right, in 5.1, it's actually kind of interesting that if we get a problem like number 3, everything's good. You just factor cancel state domain restrictions. The problem is, and I tried to focus on this in the first part of the assignment, is that the problems don't always look this nice and pretty. Sometimes they look like these algebra 1 problems, and there's a huge difference. So let's talk about what the difference is between a problem like number 1 and a problem like number 3. Okay, here's the main thing I want you to notice. Number 1 is a product. Now, why is that super important? I want you to listen very carefully to this because it is the secret to the entire chapter. In here, there are multiplication signs. Why is that significant? Because that means I can reduce this. Because when you think about the order of operations, in order to reduce division, I have to have multiplication. And in this problem, check, I do. The problem I have over here is that I do not have multiplication, I have subtraction. So the overall gist on this problem is I have to come over here and factor, because once I produce factors on the top and the bottom, I will then have multiplication. And when I have multiplication, that is when I'm permitted to reduce. Please remember that this is super bad math. I'm just going to cross this out. I'm going to cross this out, and I'm just going to make stuff up. You have to factor in order to cancel. Now, I do understand why that's confusing, because when I come over here, you can, in fact, just start canceling. Why? Because it is a product, and the other problems are not. So let's talk about how to do the algebra 1 problems, then we'll talk a little bit about algebra 2 problems, and then we'll talk about progressively harder algebra 2 problems. So in this problem, what you're going to want to do is you're going to want to first realize we are doing the order of operations, and the first thing it tells me to do is focus on the grouping symbol, and the grouping symbol has an exponent. So you are going to take the exponent and square everything. 5 squared is 25. Remember your exponent rules. When you raise an exponent to an exponent, you actually multiply. So that would be 20. There is a 1 here. So this would be 1 times 2 or 2. This would be 10. This would be 12. And this would be 15 squared, which is 225. Then what you're going to do is you're going to factor these numbers right here into their multiplicative times tables. No one knows the 25s, but you got to understand that things are going to cancel, and you're looking for your GCF. So 25, right? 25 is going to produce factors of just 1 and 25, and 225 is 9 times 25. Now, what would have happened if you would have used 5? Well, you would have found that there was an additional factor in the bottom. That's how you know you don't have a GCF. Like if I would have said 5 times 5 here and then 5 times whatever this is, there would have been another 5 in there, and then you would have known you didn't have a GCF. So then you cancel your GCF out. Blammo, done. For the bases, what you're going to do is you're going to take the same base and you're going to subtract the numerator's number from the denominator's number. Okay, so you take that number, you subtract 12, you take this number, and you subtract 10, okay, and then you figure out what that is. So what happens is here you have 20 minus 12, which is 8. And then here you have 2 minus 10, which is negative 8. I did that on purpose to make you think, well, what's the difference between these two things? One is negative and one is not. So if you have a negative number, it means opposite. You've got to remember that it's not something that is bad or anything like that. It's really almost like a translation. It means go from the numerator to the denominator. So if you have a negative answer in this step, you're simply going to move it to the bottom because this should be in the denominator, and then you're done. Okay, you're also going to state the domain restrictions, which come from all of these steps. And if you look at those steps, none of these could ever be 0 because this is a product. And we know about the 0 product property. So if A or B was ever 0, it would cause the denominator to cancel, which is bad. So then students will look at number 2, for instance, and they'll say, well, how do I do that one? There's no difference. I'm still going to find a common multiplication table. I am going to subtract my exponents. I'm going to subtract my exponents, and if there is a negative after I subtract, I move it to the bottom. You do not do this. You don't move this to the bottom and move this to the top. That will work sometimes, but it sometimes will make a mess. So let's be consistent, and you do every one of these algebra 1 problems the same way. okay? So what do we do with algebra 2 problems? Well, technically, there really are two kinds. So these are the two algebra 2 problems that we first see that kids literally get stuck on the fourth problem. They're like, what just happened, right? Because they come up here and they do this problem. They're like, yeah, I can factor that out. There's one thing that cancels. Everything's happy. And then you get to number 4 and you're like, what in the world is happening? I'm going to tell you a secret of math. Are you ready? Of algebra 2. If you're supposed to factor something, like we're supposed to factor this, and you can't think of the factor, then it's the GCF. And that literally happens multiple times on this paper. And that's literally the issue with every one of the problems that people can't do, is they forgot about GCFs. Let me show you what you never want to do. You ready? Do not ever do this. That makes no sense. Is the bottom a product? Nope. If you don't see a multiplication sign, you cannot cancel. So what you do is you are going to divide out that 3x, right? So you're going to divide out the common factor on the bottom. Divide by 3x here, you get 2x. Divide by 3x here, you get 1. Please beware of making this mistake. That happens a lot of times. Kids will be like, oh, 3x and 3x, they cancel. No, they don't. They divide, which makes 1. And then once I have that, that's when I can cancel. You see the difference here? Now I have a product. Remember, you're looking for a product in order to cancel. All right, and then I reduce. Please keep in mind if something is completely gone, it's a 1. So people will say, where'd you get the 1 from? Multiplicative inverse is 1, right? Remember, 1/2 times 2 is 1, right? So that's the multiplicative inverse, which is really just called division. And then what I did was I reduced that, and I got these domain restrictions by setting each of these not equal to 0, just as a quick refresher. If I set 3x not equal to 0, I would get x does not equal 0. And if I set 2x minus 1 not equal to 0, I would get x can never equal 1/2. You're finding anti-solutions, just like in the other chapters you found solutions. So then kids are like, okay, this paper seems easy, but then I get to a problem like number 5. And I'm like, number 5 doesn't make me happy, Mr. King, because I don't know how to factor that. Here's what you need to remember about polynomials in algebra 2. Okay, listen carefully to this. You ready? Rational expressions are actually polynomials from last chapter, 2 of them at a time. So imagine I gave you just this problem last chapter. Would you like it that way? No, you would have to put it in order. So you have to remember that you just took a test on polynomials in order to do okay with rational expressions. So you take this rational expression and you think, oh, it's really a polynomial divided by a polynomial. And you rewrite it in order as negative t squared plus 25. And then you remember this rule that if you have a negative coefficient, the first thing to do is to take it out. And now you can factor it, right? Because if I take a negative away from a negative t squared, it becomes positive. But and remember what we're really doing, if that's confusing, forgive me, what we're really doing is dividing by -1, right? So maybe that'll help. And then I can factor this pretty easily because t squared minus 25 is 5 times 5, giving you t minus 5, t plus 5, and then the denominator will cancel, giving you your answer. Kind of ran out of room, so I put the answer over here. And so that gives you your answer. And notice I distributed the answer because of the SOL, right? The SOL is going to distribute. If you have a number on left over that doesn't cancel, it's going to distribute that. And then I have my domain restriction that t can never be -5. The same thing happens in number 6. It's out of order. So notice that what I tried to do was give you a surprise followed by the same surprise, right? So looking at some other problems that come up, let's just go over the typical issues we see. Okay, so students do a pretty good job down here, and they're like, okay, so no big deal. This is like doing the problems above. Okay, no big deal. And then they get to this problem and they completely freak out. Why do they freak out on this problem? Because they're like, that's not quadratic. What do you do if you don't have a quadratic? What do you do if you're supposed to factor and you can't factor? GCF. Do you get what I'm saying? So like this one, yeah, this one has a factor of 5. So I take out the 5. This one has a factor of 6. So I take out the 6. This one has a factor of 4, so I take out the 4. This one has a factor of 5, so I take out the 5. All right, and so you can see what I did down here is I took out those factors, okay? And then I also factored, in addition to those factors, I also factored a couple more things because even though I took those GCFs out, right, I still have like a 4 and a 6. So what I did next, okay, is I took the 6 and I wrote that as 2 times 3, and I wrote the 4 as 2 times 2. It really helps to go back and scratch things out, okay? And then let's start canceling, right? So the 2's will cancel, the 5's will cancel, the 2x minus 1 will cancel, and then I have a 3 and a 2x minus 3, and then I have a 2 and an x minus 2. So it's just like the other problems, but it involves integers and GCFs, okay? So once I do that, of course, they're going to distribute this thing in here, the SOL or the SAT will. So we end up getting 6x minus 9 and 2x minus 4, and then we state our domain restrictions from up here. This will give us our domain restrictions. So we're doing pretty good. You know, this is where people end up. They come down here and they get to number, you know, they do number 5 and they kind of understand the GCF idea. Then they do number 11. They're like, thank God there's no GCFs. Everything's good. And then they get to number 12 and they're like, is that a cube? Yes, that is a cube. Okay. Now let me walk you through this problem. Okay. The point of this problem, students, is to help you understand that polynomials create other things. So when I look at this problem, I'm going to go ahead and try to factor what I can, and then we'll talk about the other factors, okay? So does 49 factor with a minus? Yes, that is 7 times 7, right? That's going to give me 0x if I subtract them. So -7 and +7. I'll save the cube till the end, right? This cube right here, we can just wait and review that in a minute. But I want you to watch this, and this is critical. This is super important. So let's try to listen very carefully. Does 4 with a 1 times 4 and a 2 times 2, can that ever add to give you 2? The answer is no. It's either going to give me 5 or 4, and that's where people freak out. They're like, what do I do? If something doesn't factor, you just write it down again. And let me say this very clearly. The purpose of these problems is to cancel things out. So I bet that this thing right here is going to have something to do with factoring this cube. I bet it will. I know it does because I made the problem. But you get what I'm saying? Like, the purpose is to uncover common factors. So this thing that didn't factor, you don't need to break out the quadratic formula. We're not solving. We're not solving. So then down here, we're going to have like a 2 times 7, which will give us 2 and 7 make 9. And now let's try to remember this rule. So the x cubed is really x times x times x. And the 8 is really 2 times 2 times 2. And we're going to do the cube rule, right? The cube rule looks like this. And so we're going to have for the x, an x, skip, x, x. And then we're going to start here with the 2, 2, 2, skip, 2. We're going to square this thing, and we're going to square this thing. And then we're going to clean it up with SOAP. Okay, so same sign, opposite sign, always positive sign, and then that will give you this, right? X plus 2, x squared minus 2x plus 4. And that's the same thing that didn't factor on the bottom. So I know that it seemed hard, but it's almost like a hint. This part right here, this part in this place here, if I click the right thing, there we go. This is actually like a hint. It didn't factor, that means it's got to cancel. And so then you get to have like an awesome, fun time here. Hi-ya, yeah, 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 whatcha, hi-ya. And all you're left with is x minus 7. Don't forget your domain restrictions. Now, that being said, some kids will say, what about this thing? I actually got some emails, and that's why I wanted to make this video so that people could watch this and have a little bit of an easier time. This thing right here uses the quadratic formula. And every time we did that, because many of you just, you just finished your reassessments on this on Friday. It was only just a couple of days ago. So when we did the quadratic formula for this, or sometimes we completed the square, this one would actually be a good one to complete the square with, we never had any real answers. They were always imaginary. If they're imaginary, they are not domain restrictions. Domain restrictions are only real numbers, right? How can something that's not real create a problem in the real solution set? It doesn't. So you actually get to ignore that. Basically, it just crosses out and it's out of your hair. Problem solved. Everything's good. Okay, hopefully that makes sense. So my only domain restrictions come from here and here, but not this. This produces nothing that's real. Okay, so the next thing is on the back. We start to do division here. Okay, so division is the whole keep, change, flip. So once you do the first couple problems, we're going to keep, we're going to change, we're going to flip, so nothing changes. Same thing here, same thing. Hey, look, GCFs. So it becomes very routine. Specifically, though, one of the ones that I'd like to talk about is number 17. Okay, so rather than do these problems that are a little bit like ones we've already done, let's take a look at 17, because number 17 requires a little bit more advanced factoring. So it is division. So we're going to keep, we're going to change this to multiplication, and we're going to flip this. To save space, why don't you just flip it right here? I do that all the time. I'm going to put 2x squared plus 7x here plus 3. And then I'm going to put this one on the numerator. Okay, once I do that, I'm actually going to go and scratch this out. And that saves all kinds of room on your paper. If you're writing this down on paper, you might just want to write it down correctly rather than write the division sign, because the division sign doesn't really exist. It's really keep, change, flip, right? And so anytime you do a problem, you just draw one big line and you decide, well, what's on my numerator and what's on my denominator? And I would start with things that are easy to factor, like this thing. This thing's easy to factor. It's x plus 1, x minus 4, right? 4 and 1 subtract the 3. And this thing right here, it's pretty easy to factor, right? Because 6 would be 2 and 3. So I'm going to have, x plus 2, x minus 3, right? And of course, I got those from 2 times 3 here, right? 2 times 3 will give me 1 if I add them correctly or subtract them correctly. And 4 would be 1 times 4 to get 3. So what do I do with this thing? I got to break out the box method. I mean, I don't want you to forget critical things. So to factor this thing, I've got to break out a box, right? And then in that box, I'm going to lock in 2x squared. You could also use grouping. I'm not going to say that that's a bad method. It's not. It's a good method. I like the box because it's visual. So then I'm going to put a 1 here, and I'm going to have 2x and an x, because I can't really change that. And a 1, I've got to have a 1 and a 1. So that would almost factor itself. Let's just double check. 2x times 1 is 2x, and x times 1 is x. And when I add these together, I get 3x. So yeah, you just gotta, I don't want you to forget your skills. So I'm not trying to annoy you. When you look at it, you realize it's not really that hard of a problem. Mr. King is just trying to get me to remember how to do the box method. Over here, if I box this one up, let's take a look here. So if I box this one, again, I have a 2x squared and a 3. This one's going to take a little more work because I need a 7. So to get a 7, I'm going to want to put, for this one, I'm going to want to put the 3 here so I get a 6x. And I'm going to want to put the 1 here so I get an x. So now I do have, in fact, 7x. So now that I've factored that using my previous skills, now I can go and have my, awesome time here trying to reduce. Not a lot reduces in this problem. A few things do, and I don't want that to make you, freak out. But always double check to make sure you didn't make a mistake. Let me say this, okay? And it's possible that I did. If you only cross out a few things, you should feel a little uneasy. In fact, I see a mistake right now. So look, do you see how right now I would only be able to cancel this and this, and then maybe only this and this, and that's all I got? I mean, that's some, but I made a little boo-boo right here. Check it out. So always double check to make sure that you didn't make this boo-boo. Look, this is supposed to be positive 1, and these two numbers right here make negative 1. Oops. Very easy to make a little boo-boo like that. So let's go back and fix it. Okay. And how did I know that there was probably a boo-boo? Because not a lot of things were canceling. And the whole point of this chapter is to have things cancel out. Not everything, but most things. Okay, so this should be x. This one right here should be the positive, and this should be the minus. Now I have 1. And let's see if something else cancels out now. So now the plus 3s are now canceling, and this is canceling, and this is canceling. Okay, that feels better. Right? So if you don't feel like a lot of things are canceling, you remember the problems are designed by me. I made all these problems to help you factor in cancel. So if you're not factoring and canceling a lot, that's probably a sign. All right, so there are your leftover pieces. And then we include the domain restrictions, right, of x cannot equal in order -3, -1, -1/2, and 4. All these things set equal to 0. You don't have to show work if you can handle not showing work. Okay, so then you have one just like your notes where you just keep flip. Don't forget when you have one like this, you're just gonna keep, change, and flip. So don't let that problem intimidate you. You just have to write it down correctly. So what about a problem like this where there are 3 things? You only keep, change, flip the part that you need to. Like you don't flip this, you only keep, change, flip that. And specifically, I want to look at this problem. A lot of people had trouble with number 22. Number 22 is the hardest problem on your paper because it's just a lot of things in one problem. So how do you go about a problem like number 22? Like, how do you start it? You look for division and you deal with the division. So the first thing I'm going to do here is I'm going to keep this, I'm going to change this, and I'm going to flip this. And again, a great strategy is to actually flip it over in the first step and get rid of the original problem. It is so frustrating to get to the bottom of the problem and realize, oh, I forgot to actually flip that over. Man, is that frustrating. You've been working on it for like 4 or 5, maybe 6 minutes, and then you realize at the very beginning you did the wrong thing at the beginning. So flip it over and then say, bye-bye, you make me sad. Then draw a huge line all the way across your paper. And don't get scared of cubes unless you have a cube with an integer. Do you see how this cube with an integer is different than the rest of it? I want you to pay close attention here. Look, this problem is not the same factorization as that. One of them has a GCF and one of them doesn't. So when you have a GCF, like on this problem, you're just going to take out the GCF, right? So on this problem, you're just taking out an X, right? So if I take out an X here, I would have X times, and I do a lot of factoring above the problem, so I've saved space. So I take out the X, and here I get X squared minus 4. So you're going to come down here, and you're just going to write 2 factors down. And of course, I'm going to help you with this problem. I'm not going to do the whole thing for you. This problem right here will just factor normally, right? That's just a normal quadratic. So I'm just going to write down 2 factors. And this problem right here, after we flipped it, is also just a normal quadratic, but it doesn't factor. And you might say, how do you know it doesn't factor, Mr. King? You've got to remember how this works. When I look at this 15, the 15 is going to be 3 times 5. And if I subtract them, I easily get 2. Over here, I have a 9, and I've got to add. So 1 times 9, that's 10 if I add them. 3 times 3, that's 6. So why would I put a non-factorable quadratic in an expression? Why? Because it's going to cancel with something on the bottom in its entirety without having it be factored. Don't be afraid of these. They're a hint. They're like basically saying that's going to show up on the bottom somewhere. So let's see where that might happen. So on the bottom, nothing here that's special, just 2 factors. And then guess what? It's the cube rule again. You know what part of the cube rule is? It's probably going to be this x squared minus 3x plus 9. So I'll set that up. You know, this is going to be x times x times x, and this will be 3 times 3 times 3. And your job is going to be to put that here. I'll give you a bigger space, and I guarantee that this is going to cancel with this. It's going to happen. Okay, just make sure you do it for real. Don't just guess. And then the last part here, there's a GCF in here of 2x. So if I take out the 2x, that problem will factor. You get 2x, x squared minus 4. So it actually will factor again. So yeah, that problem is a big, fat problem. It is like all the factoring you've ever done in your life on one thing, other than grouping. Grouping is the only thing not in there. I actually considered putting grouping in this problem, and it kind of made me feel a little bit like uneasy and queasy. So I took it out. I figured, hey, cube rules enough with all that GCF. I want to show you one last problem, and I think that'll be a good starting spot, especially for people who are maybe watching this who couldn't attend class or something. So the last thing I want to show you is when you come down here to like a problem like 24, this problem is actually very easy because it's all factored. All you have to do is keep, change, flip, and cancel. And then even a problem like 23, you might be like, well, Mr. King, 23 scares me because there's a negative sign on it. But what does negative mean? Negative means move me to the denominator. So if I move that to the denominator, right, if I put this on the bottom, and then I just rewrite it, right, it's really x plus 2 over x minus 1 divided by x. And then the only thing I do in the first step is just rewrite it correctly as x minus 1 on the bottom. And if I flip this one step, it's done, right? Yeah, we might as well just show that to you. So x plus 2 over x minus 1 times, flip this over, you get x minus 1 over x. I think you can see what's going to happen there, right? So some problems are not that hard. They're just trying to get you to understand what to do and how to do it.